So today's problem of the day is equal sum grade partition second. So yesterday we have done the equal sum grade partition first problem, and this is like the after that it is the second problem. So what is there in this problem is like you are given an m cross n matrix grade of positive integer, and our task is to determine if it is possible to make either one horizontal or one vertical cut on the grid. And what is the condition? Each of the two resulting sections formed by the cut is non-empty. The sum of the element in both sections are equal or can be made equal by discounting at most one single cell in total from either section. The third condition is if the cell is discounted, the rest of the section must remain connected. So there are three conditions, and what is like if there is a matrix having suppose n rows and n columns, then what we need to find, we need to make one cut either on horizontal or at vertical, and by making the cut we can divide the grid into two partitions, and the two part sum should be equal. And what are the condition is like the one cut should not be empty, one part should not be empty, and the second condition is if both the section sum is equal, we can even do one more thing. Like there's one more case. Like after making partition, we can exclude one element as well from the sum. And after excluding that element, if that sum is like sum 2, and this part sum is sum, so that sum 2 is equals to sum, this can also be the valid case. And the third is like if the cell is discounted, the rest of the section must remain connected. Like if we are removing the cell, the section should be connected. So like it is not like the case if there are so many cells, like if there is like this, and if we are removing, like suppose this we are removing, then it is dividing it into two parts, like it will not remain connected. To remain connected, we need to see key like which cell we need to remove. And a section is connected if every cell in it can be reached from one other cell by moving up, down, left, and right through other cell in the section. So if we will see in this solution, there can be like we have done this yesterday the partition one problem. In that problem is simple. If there are n rows and n columns, we can partition it and we can divide it into two parts, and the sum should be equal. But here, what is the addition is like we can remove one cell also, and after removing that cell, if that sum is equal, then also this will be the valid case. Like we can remove the cell also, and we should not remove the cell also. Depend on our valid case. So how we will do this? Like there are some conditions. Like we need to check for all the horizontal cuts as well as the vertical cuts. So instead of doing for the horizontal and vertical cut, what we can do is like if there is a matrix, then if we will rotate it, then it will the columns and rows will be exchanged. So if we will try to get the condition for only the horizontal part from one matrix, and if we will do the rotation of this, then the rows and columns will be exchanged. If the rows and column will be exchanged, automatically it will be the vertical for the other case. So what we can do is like we can there will be a one matrix, and what we can do in this matrix, like we can find for the all the horizontal cuts, and instead of getting the vertical cuts, what we can do is like we can rotate it for all the sides. So we don't need to find the vertical case, and we only need to cover the one part. Like if we will cover for the horizontal cut, then this one part we can cover if we are removing the cell from this part or not, then we can cover this. Then if we will rotate it, it will automatically cover for the, if we will rotate it by 90 degree, it will automatically get covered for the top cell, and if top part, and if we will rotate it again it by 90 degree, then that it will get rotated by 180 from the this original. So this, the part what is there in this side, it will come to this side. So it is like we are removing the first part of this. So like in this case, like we can consider all the parts in like rather than to compute for the two parts, we can only can do for the first part. And if we will rotate it three times, then it can cover for the all our scenarios, all our parts like top, left, for bottom, right. So yeah, so we will look into the solution. So we'll see the solution. So what we are doing in the solution is like we have defined a total. Total is like we can store the total of total sum of the grid. And there is one more thing, like if there is a matrix and suppose we are making the cut like this, if that sum is like sum 1 and this is sum 2, and after removing this, suppose this value is like x. So how we can find the x is x, if we will do the sum 1 minus x is equals to total minus sum 1, because both the sum is equals to total. So from that, if we will try to find x, and 2 into sum 1 minus total is equals to x. So from here, we can get the value of the cell. Now what we can do is like we can create a set we are creating to store the value of this cell. Like we will traverse through all the matrix, and if we will get the value of the cell from that set, then we can say this is a valid case. Now if we will traverse to first, what we will do, we will try to find the value of the sum by traversing through all the matrix. We will get the total sum. Then what we will do is we will move this from 0 to less than 4. So what it will do, it will rotate our matrix three times. So like we will get the scenario for all the parts like left, bottom, right, and top. And what we are doing, we are initially clearing this, and we will insert it the 0 in this. So clearing means we will clear the set, because every time we will traverse through the other rotation, then we need to clear the set value, because otherwise it will get repeated. Then we will insert the 0. 0, why we are inserting 0 is like, because 0 is also the valid case. 0 is like we are not removing any cell, because our condition is like x is equals to 2 into sum minus total. X is 0 means sum is equals to total by 2. So this is also the valid case, because in this case we are not removing any cell, and we automatically got the answer. Now what we are doing is like we can check m is the number of rows and n is the number of columns. So if the number of rows is less than 0, then we don't need to do any partition. Suppose n is the number of rows. If there is one row only, then how we can partition the horizontal partition, how we can do it? We will not be able to do, because we need we can't do empty part. Should take at least one part. So we can't partition like this, because we are trying for the horizontal partition. We are not trying for the vertical, because we are rotating it three times. So automatically that vertical wala will cover. Then what we will do is like we will try for the horizontal partition. If there is only one less than two rows, 1 or 0, then we can't can't do horizontal partition. So in this case, we simply can rotate our grid and we will continue. Like continue, it will go to the next rotation. If it is not the case, then what we can do is like if n is equals to 1, n is the number of columns. If number of columns suppose is equals to 1, like there is only one column, then what will be the condition is like we can't remove this middle cells. We can remove only first cell if we are doing partition like this. We are doing partition. This is the partition. Then we can't remove this cell because if we will remove this cell from the top part, then this board will be divided into two parts, and we have to make it connected. So we can't remove like in the middle. So if the number of column is equals to 1, then what we will do, we will traverse through all the rows and uh, we will sum all the values and we will try to find the tag value. Tag value is 2 into sum minus total with the help of this. And if the tag is equals to 0, then that means we are not removing any cell. If the tag is equals to 0, 0, 0, that means this is the top row or the bottom row. Top or bottom row we can remove. Otherwise, in middle cell we can't remove. If it is a tag is the top row, bottom row, or without any removing cell. If the tag is equals to 0, then we can return the true. Otherwise, we can rotate the grid and we can continue. After that, what we can do if our column is not equals to 1. If the column is not equals to 1, then what we will do, we will traverse through all the rows and columns and we will insert our value to the set and we will try and we will sum all the values of that row. Like if there is a matrix, and if we are traversing through this row, then we can, if we are traversing through this row, then we can get the value, some value of this row. If this is the sum value, then what we will try to find the tag. If the tag, if the I equals to 0, then that means if there is a, this is the like first row. And what we will do is like, if this is the first row, then there is a three case. Like we can remove, we will not remove anything. Or this is like the first column, or this is like the last column. Because if this is the card, then we can't remove like middle values. The first value we can remove or the last value we can remove. So if that is the condition, then we will get the answer from this, then we can return to, otherwise we can continue. If I is not equals to 0, like this is not, the partition is not this, so like the first row partition, then we will try to find, then we can try to find this tag value in the set. Because if this is not the first row, then we can get the tag value from anywhere. Then we can simply return the true if the tag value exists, and we will do the rotation for the next rotation, and then we can simply return false. Now we will see the time complexity and space complexity. And here, yes, this rotation, we are doing the rotation. How we are doing the rotation is like we will traverse through, we will create this other vector, the new grid vector, and what we will do, traverse through rows and columns. And this is the condition to make our grid 90% rotated, 90-degree rotated. Make our grid rotated by 90 degree. So we will rotate it by 90 degree, and with the help of this condition, we will get the new grid. And after getting the new grid, if we will see the time complexity, then it will be like this time complexity is big of n into m. And this is also like two loops only we are, because this is like constant, and 4 into m into n, m into n only. So m into n is the time complexity and space complexity also. Space complexity is also m into n because we are using this extra vector. Thank you.